Good morning, everyone. It's my pleasure to introduce Mr. Suresh Mani, South Zone Head Technical Services, handling PP grades of choice for auto sector. He is a polymer graduate from Crescent Engineering College, Chennai, with more than 16 years of experience in this field. He has started his journey with IOCL in 2008 and has established product development and application development. And he is specially trained on technology know-hows of PP Speriol technology products at Lendal, Basel, Italy. I welcome him to give a speech on PP grades of choice for auto sector. Thank you. I also welcome Mr. Sun J. York from Kingfa Science and Technology Limited to talk about carbon neutral and sustainable material selection. Mr. York is a postgraduate in polymers from China. He's been working in engineering polymers and he's been associated in this field for the last 13 years. He started his journey as a technical engineer. Currently, he is the head of the department. And he's developed expertise in carbon-filled and carbon-reinforced thermoplastics. He has developed lightweight alternatives for metal, wood, and PP composites, PP honeycomb panels, and long carbon fiber reinforced thermoplastics. He has written a lot of papers and has a lot of patents to his name. It's a pleasure to welcome him to give a speech to us. Thank you. I now welcome Mr. Suresh Mani to come and give a speech.
Okay. Okay, fine. Is it forward? Okay. Okay. Thank you, Karthick sir, for a wonderful introduction. And Vanakkam and good morning to all. Let's start the first part of the presentation of this thing. We would like to talk about the polypropylene grades for the automotive sector. And today, all the raw materials, whatever the products you take, almost 80 to 90% of the products, cost of the products is from raw material. So the opening justifies that the raw material is the major this thing for the concern of all the processes. And I like to touch upon the polypropylene specific grades and what we offer in terms of sustainability as well as in terms of the recycling point of view, and also for the various solutions what we developed for the auto sector. So this, skip. So majorly we will look at the material requirements for the auto sector, like Senthil Kumaran sir has already touched upon the various, he has given the entire bucket list at for a really challenging for a raw material manufacturer also, as well as for the entire auto industry, I would say, from the lightweighting point of view, from the biopolymers or recycling point of view. So I'll just this thing summarize on the this. We have a corrosion free material, it's a standard thing, anything for the life of the vehicle, it should be a corrosion free material. And whatever product we are looking, the material should have a design freedom. It should be easy to adapt to the whatever we are thinking. Senthil Kumaran sir has touched upon 18 months, we have to work it on the digitalization. What we have to imagine 18 months when the conceiving the product, how it be. So the material should be selected, should be fit into that all this conceptualization stage to get into that. So whatever the material we select, it should have give sufficient design freedom, adaptability, and integrating with other materials. Like when we have two materials fastening together and it doesn't have any core, it doesn't fail during the put into work, and all those things will be it will be considered at the material requirement for the automotive sector. And most important thing on the safety point of view, like we should be like always we should touch on the safety. It's the prime most important for the material. And last but not the least, on the recyclability, we should all, as clearly pointed out, the biopolymers and recycled plastic content increase. So entire this drive is towards on the recyclability. Whatever the material choose, like it has to be on the recycled front. It should be recyclable. Moving on to the basically I am from a plastic side. Like I will just touch upon like the plastic is the material of choice for the automotive. Like basically currently it's almost 26 million tons of vehicles we are producing, and it's projected to grow by 2030 almost 85 million vehicles. So which is more than the 3 times of what we are producing right now. So whatever the challenges we are right now, it is going to be get tripled. Like in the material availability, it should go, or the entire raw material, whatever the processor capacity, all the things has to be tripled by the end of 2030. So we must be like looking at the material point of view as well as on the this thing. Like I'll there is a only 3 materials are projected to grow when we go towards a 2040 kind of a scenario, like where in automotive, particularly the lightweight material like aluminum composites as well as the plastics. So these are the material is projected to have a higher consumption in terms of the share. Plastics is almost having a half of the volume of usage in car, but it constitutes around 10% of the overall weight. So that is a major growth will be there in plastic segment. And this once we reduce the weight of the car by 1 kg, we can achieve almost 20 kg of carbon dioxide emissions. And the usage of plastics will derive towards the fuel economy, lower carbon emissions, and better recyclability. And there is some of the examples like we already done it, the industry already done it, and industry is moving towards the better challenges, and and the challenges is equally supported by a lot of plastics and its composites. To give you overall this thing, in a typical automotive, we are using close to 30,000 parts. And out of 30,000, almost 10,000 parts is made of plastics. So if you think of out of 10,000 parts, we are using almost 39 different types of plastics. You can have from polypropylene to all kinds of styrenics and everything. So if you basically see, it is being 70% of this 10,000 parts, we are majorly using polypropylene and polyurethane, PVC, and polyamides. So out of major this thing is polypropylene and its base compounds or composites. So I'll just touch upon this polypropylene. What we require as a compounding in automotive, in polypropylene we have 3 different variants. We have a impact copolymer, we have a random copolymer, and we have a PP homopolymer. So in auto sector, we usually use impact copolymers as well as the homopolymer. So impact copolymer, it can replace some of the applications, and mostly it is in a compound point of view, it is used in a combination with the homo and impact to get a desired stiffness and an impact balance. You can see the homo part as well as impact ICP part, impact copolymer part, along with various different types of reinforcing agents to get the desired, what you desire, like that kind of a formulations that can be developed. So PP has a wide, like you can mold it according to what you want, like develop according to, it's a most versatile material and you can develop accordingly with the kind of combinations you want. And that's why PP compounds can easily replace the styrenic compounds as well as polyamides compounds, as well as it can also touch it upon the polycarbonate based compound. So what we require from PP, it should be a high mechanical strength and good impact properties and high temperature resistance. So and color and flame retardant as the one of them. So polypropylene, as I say, like it is the best suited material with the kind of adaptability it can be for the auto compounds. So this data to showcase that on the material perspective, like it's always a demand from the processor that there is a lot of scarcity of material. Like as we had discussed in the morning also, like 50% of some of the processor is importing the plastics, like for their consumption. So where I can where Indian Oil and other resin players can support, because we have to give them what they want, like what they want and what like on a regular basis, and we have to enhance our production capabilities, enhance our technological capabilities to support them for this kind of a development. So with the production numbers, almost 23 million vehicles we are producing in last year, and we are consuming almost 1 million metric ton of plastics in this 23 million vehicles. And out of that, almost 3 lakh 20 tons of plastics is only polypropylene is consumed. So it's equal to one single line of production of a normal polypropylene line. So that much of requirement is there, which is projected to grow almost triple. Based on the data, it is projected to grow triple. So we need at least 3 PP dedicated lines for supporting the automotive. So currently, only auto sector. There is a n number of infrastructure, packaging sector is there. So what we are doing, like I will just explain on the further slides what Indian Oil and how what we offer with the to support this kind of a requirement. Before to start with, I'll just give an overview of Indian Oil. Like we have Indian Oil, you know, it's like we have into energy, like petroleum products, and we have moved on to polymer products, and we are also moving towards sustainable energy like aluminum air batteries. We have a collaboration with Israeli Fin Energy, Israeli company, and also we are into our R&D is working towards hydrogen powered fuels, and also we own close to, out of 23 refineries, Indian Oil owns close to 11 refineries, and each refineries we are trying to integrate our products with petrochemicals to get to support the growth of the entire sector. And also we are having a 3.2 million metric ton of capacity of petrochemicals right now. This is the journey of Indian Oil in petrochemicals, and we started our journey in 2004 and with LAB, mainly into detergent and soaps for the petrochemical point of view, and we moved to PTA, purified terephthalic acid, which is again base chemical for your polyester fibers. PTA and MEG will give you polyester fibers. So we started manufacturing PTA in 2006. Then we moved to, in 2010, we started our naphtha cracker plant, which has given the polypropylene and polyethylene at Panipat. We have produced Panipat with an investment of almost 15,000 crores. And we have started the next, moved on to from C3, like for propylene based products, we have moved to butene based products, butene, butadiene, and we have moved to styrene butadiene rubber with a JV. Then we have moved on to, with a big significant step, we have moved on to putting up a plant at Paradip with a capacity of 680,000 tons of polypropylene. And we have we have already invested 24,000 crores in petrochemicals, and we have plans to invest up to 35,000 crores in the next 5 years for production of various petrochemicals. And we have already, our board has approved this polypropylene lines in Baroda, Baroni, and we are coming up with one more plant at Panipat, and we are coming along with our JV CPCL at Nagapattinam. So all these plants will put up double our capacity what we are having right now. From 3.2 million metric ton, we are going to achieve 6.4 million metric ton by 2025-26. And by the end of this decade, like 2030, we will have a petrochemical capacity all put together on the fiber side and on the polymer side. We will be having close to 13 million metric ton of products. So it's almost from 3 to 13 million metric ton of products we will have to support this entire development. So just to talk about, because it's on the technical perspective, like I want to touch upon on the plant side, like we are producing this polypropylene from Bleondal-Basel technology. We have total 4 lines right now, 2 lines each in Panipat and 2 each at Paradip, Odisha. So south, actually we are catering mostly from Paradip for the homopolymer requirements, and Panipat where our copolymers production is currently at Panipat. And also, like, we have a dedicated HDP production line at Panipat, and we have LLDP production line at Panipat. So it's almost like we are giving close to 52 different grades, like put together polypropylene and polyethylene. So just to talk about on the technology side, because there is a lot of compounders who is looking after impact stiffness balance. Like Spheripol technology is the best technology to give the impact stiffness balance, and it has been demonstrated by the Bleondal-Basel quite often, and we have almost 50% of the global PP is produced by Spheripol technology. And because of the wide range, we can achieve the MFI range from 0.3 to 1600, and from xylene solubles around up to 99%, and fluxural modulus close to 2200, so on. Like overall, we also have our technologies with our downstream equipments like a twin screw extruder to support the better homogeneity of the product. So I'll just touch upon some products what we offer. So this is 60 MFI homopolymer for compounding sector. This grade, this was first introduced in India on a beaded form by IOCL, and this grade is typically high MFI. Actually, Sendil Kumar sir has talked about the high MFI and high gloss requirements, so we have launched this grade with high MFI, not only high MFI, with a high stiffness also, where you can reduce the other filler content. So we can able to give the better balance of stiffness as well as the impact strength. So this is one of the grade. This launched in last year from Paradip. And moving on to the other grade, this is 3030 mg. This is a 3.5 MFI grade for your where you want the impact stiffness balance in a ideal condition, like you want a seat base cover and fenders and steering wheels. And we have a 4080 made. This is particularly, it's a general purpose grade where you want mainly goes for paint pale application, or you want in any kind of a general purpose formulations also, like 8 MFI, but with a superior impact strength. And moving on to 3120 MA, it's a 12 MFI grade, and it is mainly into where you want like 1300 FM and more than 100 impact strength. So the impact stiffness balance again plays a major role, and with a higher MFI. And this grade we have launched this year, and with 25 MFI reactor grade. most of the high MFIs are a cracked grade where you have higher VOCs. So what we have done is like we have produced a 25 MFI reactor grade, and to reduce it has a low VOC emissions, and this grade is ideal for most of the high MFI formulations, and therefore also white goods, appliances products. And we have this 65 MFI grade, and mainly for appliances components as well as auto thin wall injection molding components. So this 4015G, I'll just touch upon, this is a 1.5 MFI for your blow molding containers and extrusion coating grades. And this is a battery grade, like wherever you need a high heat resistance or high like HDT, this 4100mH grade where these battery components, it is being approved by all major battery OEMs, Exide and Amar Raja. And these are 5080mg, which is a no break grade. We can give the 10 MFI ICP grade with more than 500 impact strength. And there is a one more grade, 40 MFI ICP grade. So due to time constraint, I am just moving on. Like moving on to the most critical part, like formulation, what we developed for IOCL for the automotive sector. This is a 30 MFI no break grade, which Indian Oil has developed, and there is no manufacturer currently in India. It is most of the requirements are being met by imports. And 30 MFI no break grade, like currently no break grades are available by all the domestic producers only in the range of 10 MFI. So we are offering this grade at 30 MFI with almost 600 impact strength and at a very good stiffness level. So these grades can be explored, and this will be commercially launching soon. Sorry. We also developed one polyacetal replacement grade, we can have this replacing engineering plastics, where it is targeting the replacement of polyacetal with a better stiffness as well as impact strength, and also like it a reduced density. Our density is close to 1, but whereas commercially available polyester is 1.4. So with reduced density, lightweight, and better impact stiffness balance, polyacetal is also one of the development. It's a PADC developed compound, so we can share the formulations and data with the process. Then our grades are approved by major OEMs, like I'll just skip it. And most critical part is all the compliances, like it has to compliance with FDA, REACH, and ROHS compliant, SVHC. So our all grades, biocompatibility, all grades are like gone through this entire process, and it is being approved by all these DMF certification also, like all these compliances, and we can give the declaration as and when requested by the customer. Then plastic neutrality initiatives, and we have not only speaking on this point, like we have launched these 2 grades, and on September 2022 under the brand name of Cycloplast. And we have launched the 2 grades. One is PP 11 MF5 homopolymer 1 RMF 120 for the for all the applications in the 2 colors, like black and white, and it is available with us right now. Like commercially we have started the sales, and we have one more grade. It's in the recycled blow molding HDPE. That is also 1.5 MFI, used for mainly for the lube oil containers and this thing. So these 2 grades are commercially available, and we are moving on to further on the sustainability front, and we have plans to launch almost 15 grades in this recyclate segment to support the entire spectrum of the industry. We have a technical support at PADC. We have 2 PADCs, actually one is at Panipat and Paradip, and we have a dedicated R&D facility at Faridabad, where they work close on the catalyst and additives. And we have PADC mainly works on the application related to the customer. What customer needs, that will be fine-tuned at the Product Application Development Center. and we can work jointly and with an NDA and all, like wherever you want any testing support or technical support on this regard. And these are some of the facilities. Like we have a stretching line also, like in addition to that, we have a dedicated plants which we can test and try at our in-house facilities. Thank you. Thank you.
Thank you, Mr. Suresh Mani, for giving us Indian Oil's support to the plastic industry. Now, I welcome Mr. York to talk about carbon neutral and sustainable material selection. Thank you.
Good morning. This is my first time to join Institute Plastic, Indian Plastic Institute. So it's my honor to be here to share some development from Kingfa PCR material and how we try to reduce the carbon emission. Okay, so my topic about 5 parts. So first I introduce the carbon neutral strategy. Second one, how we make this PCR material. And last one, how to calculate this carbon emission. So, and what's our next plan? So as we know, recently the climate change is very huge. So I think everyone is have this kind of feeling in our life. So what the issue is the greenhouse gas by human. So it's much more than our nature. So this is how to make sure the temperature increase in globally. So this is a bigger issue for us. So this is global warming potential is there. So we need to do some work, try to reduce this kind of trends. This is one map about every country. What's our target time to make the carbon zero? So some country already meet this target, but for India, for China, I think we planned in China is 2016, we can meet the carbon neutral. But in India, it's about 2017. So why we need so much time? Because in China and India, we have so many population. We need development. The energy consumption is much more than other countries. So, but we should think about how to achieve the sustainable development. So in Kingfa, we have some target. We also try to meet the carbon neutral by 2016. So this is our promise. For the PCR consumption, so now major the resin is polypropylene, then is polyethylene, then is polypropylene. And the major application is for package home appliance. Okay, so in last year, the China for the auto who use the recycled material is 3.5 million ton potential is there. The second one is I want to share our sustainable material solution in China. We have 3 plants, 2 plants in China. One is in the north, one is in south, and another plant in Malaysia. So this is our planning to build a more pre-treatment machine to make the PCR material. And our logo for this PCR material is RICO 1. First, I want to share one video about all the pre-treatment machine, what it look like. So this is the HDPE, like a milk bottle First, we remove the water liquid from the bottle. Separate to nature color, some dark color. Also, we have some electrical static separation system. So this can separate the ABS, PP. So this is a washing system. So this is user density. All the PP is floated on the upside. This is after we recycle, after we regrind, then come to the compounding. This is a utility to remove the dust and the fume and the water treatment. Okay, so this is our pre-treatment plant video. So from this PCR, what we can do? First, we need to collection from our consumer. After we use this part, then we need to collect, to separate, then to package. The second one is what we're doing is doing the pre-treatment from the, just like the video already shared. Then finally, we compounding to the granules. So the most important for PCR is the raw material, where we get this part. Some part is like a pot, some is like a fishing net. So this is all kind of PCR, what we get. So what we can, to make sure we can achieve this, we need the platform. The first one, we need a supplier who can give the material to us or part to us. So we have a 10 strategic partner. Each one is more than 10,000 tons per year. Then also we have another 50 small suppliers. But the most important is this 100 recycled center, because they should to separate to different locations to get this material, to get this part, then share to us. So this is what we want to, Kingfa want to do this collection system. Then after this part come to our plant, then we'll do the pre-treatment. So after the regrind, then finally we making this final granules. So this is the one is PP. Two example. One example is from the washing machine, the PP material. Then we regrind to the small pieces. Then get this PP granule. Another one is from the nylon PA6. We get from this fishing net, then also do the regrind, crushing, washing, then get the PA6 material. So this material, now we can supply to our customer. So this is the material, the property, what we can get from this kind of material. So this is the best material we can get. The color is very white. Also, there's no many black dot. So some customer, they're asking this requirement, but some customer, they ask black color, then it's much easier to achieve. So For this PCR, what we need to control, the quality is very important. All the related to mechanical, long-term aging, and also the VOC and appearance, this is what we need to take care. So this is CPK analysis. We get the analysis for the MFI and the density. So if we can control the raw material, actually we can control the quality. So this is, but still with our processing, we can do some improvement to make sure we can get a good property. So this slide is showing if we add a different percentage of PCR, what property will come down. But still, for this multi-axial, if we add too much recycled, it will become very brittle. But based on our technology, we use some additive and also improvement in the processing. We can get also it's very ductile material. So this, I think, is basic requirement for automotive. So what we're doing, because first during the physical recycle, it's very easy to degradation. So that means the molecular distribution is very wide. So during the processing, we need to add some additive to increase the molecular weight. The second one, during the recycle, some metal impurity, also some other impurities there. So then we need to also add some additive to capture this metal to reduce this influence. This can meet the UV requirement, also heat agent requirement. From the quality system, now we already get this global recycle standard. So from 1.0 edition, now we can achieve 4.0. The next one is how to calculate this carbon emission. So I think this is the major point I want to share because we just start to doing this work. We already spent about 6 months to get this data. What we're using is the garbage software. We already purchased this. So when we calculate this global warming potential, so this is one value because they use the carbon dioxide because there are so many different gas which can have this global warming effect. So, but finally, we only use the carbon fiber, this equilibrium. So when we calculate this carbon emission, we need to think about what's the range, what's the boundary. So from our raw material to our in our plant, then to our gate. So this is one point. The second point is from the raw material to the end of the product life. So this is what we mean. We mention is life cycle assessment. So this, if we make this PCR, we should think about this life cycle. This is one example for EP material, PP with 60% talc. So if we calculate with only virgin, it's only small part. It's from Colorado to gate. But if you calculate with recycled material, then it's from Colorado to Colorado. That means we get this product, this part, then do the recycle, then doing the compounding. So in the garbage software, we first need to set one model. How many steps is there? So from PCR, first we need to do the pre-treatment, then do the compounding, then come to the compounding with virgin material. Finally, then dispatch to our customer. So there are 4 steps. Each step will check how many energy is there, how many water consumption is there, what's the package material. So this some data we need to get from the software. So most of the data we already get in garbage system. That one is basic database. What do they have? Major is metal. But they also have another database. So this we also have this information. Because each plant, each company, their energy consumption is different. So the carbon emission also is different. But we take average value to calculate this data. Okay. So the first one, we make some comparison about the different system from Gabi, from the China Auto Association. So they also have some data. So this we can choose by ourselves how to calculate. And for the recycled, we do it by ourselves. We can check to our plant how many energy we consume. So each grade we can calculate how many energy consumption is there. So this is for each step, we calculate the global warming potential contribution. So here we can find if the material is from the polymerization, the virgin material, the GWP is very high. Also, second one, the energy consumption also is very high. But if we use the recycle from the virgin material, we transfer to recycle, this reduction is much more. So this is the two grade. The first one is with 25% recycled PP. Another one is the virgin. So if we see this, the data, we can reduce about 20% for the carbon reduction emission. So we also have some other grade like HDPE recycled, like PCABS recycled, ABS. So if we add more recycled material, the reduction is much more. So this is some data we already get. Next one, I want to share some application for this recycled material, what we already have some business or some case study. So the first one is for the automotive application for exterior, like a bottom undercover, the panel. So actually we already use 100% recycled. For PA66, for some tie, some harness application, we can also have a 20%, 25%, because this have some high requirement for the property, for the flex impact. So this cannot add too much. Another one is for the cooling fan, for the radiator tank, and the fan shroud. I think this we can also add, choose maybe 50%, 70%, even 100%. This is possible. This is another ABS recycled. This also for some interior or exterior application, we can choose some percentage. But this need to find out what's the requirement for the VOC. Because during the recycle of ABS, the VOC is very difficult to control. Another one is PC ABS, because the PC raw material, what we get is very pure. So after we recycled, this PC actually we can add 50%, 70%. So this is one advantage for the PC recycled. So this we already have some trial with some OEM to also this no influence to the painting. And some other application besides the auto, like the furniture, like the chair, like some housing, also OA, we can use this recycled because they already like Canon, like some brother, some OA, they must use some recycled. So I think auto also will have some more requirement for this sustainable material solution. The last one is the summary for this topic, because we already, for this PCR, we already started about 10 years ago. So step by step, we have more and more business and more capable to do this recycling. I think in India, we will also have some plan to do this in the future. Okay. So in 2019, we get this person sustainability prize. So this, I think, is to give us some award to confirm we already do some work to sustainable to the society. The second one, we get this ocean-bonded plastic certification from the TUV. This major due to the fish net we recycle for the nano material. So I think this is just a beginning for the PCR is just beginning. It's only physical recycle. But still, we are working with our supplier, like ExxonMobil, like Indian Oil. So we want to get a more solution, like a chemical solution, like a bio-based material. So actually, from the bio-based, we also have some 1 or 2 grade is there, but it's PA10T. Okay, so this to meet this zero carbon emission is very difficult. But I think step by step we can get some good result. Another one I think is from for each company we should think about how to achieve the zero carbon, because the major consumption is energy. So from our side, how to change the energy to some green energy, like solar, like wind. So this is one important. Second one, how to improve our efficiency, how to save the energy. Another one is from our formula design, which material we can choose to because the material we choose, we should have big influence to the carbon emission. So this is, we should focus on this high global warming potential material. So this we should give the pressure to our supply chain to achieve our target. And next one is we need to get this database. So this work is very detailed work. We spent 6 months, only about the 10 grade we calculate, because from each step you should to get the raw material data. Okay, so this is 3 points we need to think about. The last one is I want to invite all the friends, if you have time or have some plan, to join our K-show, K-fair in German. I think we have one exhibition place to share our sustainable solution. So if you join this K-fair, please come to our exhibition place, then we can have a more discussion about this sustainable solution. Okay, thank you.
Thank you, Mr. York, for giving us details about Kingfa's plans to reduce carbon footprint and sustainable material selection by using recycled post-consumer material. To sum it up, we have heard from industry expert telling us about what is the expectation of the auto industry, and we have heard from Indian Oil's expert about what they are working towards polymers to support the growth and to support the EV coming up, and reduction in the plastic weights and new technology improvements, and also from Kingfa about sustainable material selection for supporting us in the future. So thank you both. Thank you, everyone. I invite question and answers, if questions from people, if to Indian Oil expert and Kingfa expert.
This is to Mr. Sendil. About, we were talking about the batteries. Say, for example, we have a lot of, the damages or the fire in the batteries, and whereas this is not the case with the four-wheeler, whereas it's very common in two-wheeler. Is there any way we can test the batteries before we buy the vehicle, or the two-wheeler manufacturer themselves can even test and to avoid this kind of accidents, the battery bursting accidents?
So, I think it's the right question, and then a lot of concern involved, right, and human life, right. So, I think I still remember the days in my childhood wherein my uncle used to put in a skeleton and danger symbol when we all migrated to start using LPG in our house, right? I think most of you would have experienced that. So any technology has its own safety hazards, right? So I think electrification also has its own hazard. So in terms of understanding the technology, in terms of keeping those protocols in place. So this is evolving very fast. Whatever you see in the two-wheeler industry is perhaps because of some of the unique weather conditions what you have, number one. Number two is probably some kind of cutting corners and inadequacy in the testing protocols what people have. I think the government of India has kind of seen this particular thing, and I think if you are following the regulatory regime, they have preponed by 3 months about this battery regulation in India. So wherein a lot of strict protocols has been laid. So I think this will in a way regulate and lot of government things, whether it is NATRIP labs or any other labs like ARI or many of the third-party laboratories, they're all now available for testing this aspect of that particular thing. And if you really look at in the four-wheeler regime, right? So I think you guys are all familiar with UL flammability, right? At one point of time for the bus building and all those things. So that means it's not like saying that I am not flammable, right? I am flammable, but I will give adequate time for my occupant to safely escape out of the vehicle, right? So if you really look at the four-wheeler industry, so the global regulation in a way, nutshell, if you really North America as well as in Europe context, it's something like 5 minutes, even if there is an incident in your lithium-ion battery, the flame has to be contained in the box for 5 minutes before it propagates, into the main occupant space. But we do have technologies that are even developed for railway coaches, whether it is a bullet trains or all the electric trains, up to a safety margin of 30 minutes it can contain. So it kind of a foaming agent that gets formed. It's a very thin layer of 1 mm that grows 200% into the battery compartment and kind of suppress this particular heat transfer into the occupant, and whereby other flammable materials get into the act. So I think the maturity is definitely exponentially growing, and we as a very responsible OEM, we are keeping all the checks and balances in accordance with the regulatory bodies. I think rest assured, the industry is definitely keeping the human lives and values the highest order. Thank you.
Yeah, Mr. Suresh Mani, this is Mr. Suresh Mani. Good morning. I would like to thank you for your presentation. And I would like to know about what you are saying about the polyacetol replacement or polyacetol application by polypropylene. So is it in the development stage number 1? If it is developed, what is the grade number? And do you have any comparative complaints report on polyacetol and PP?
First of all, this we have developed for our in-house formulation that has been developed by our Product Application Development Center, Panipat. And it has been tried in one of the component where it's a LPG safety cap. That is a LPG safety cap right now comes in polyacetal. That we have tried and we have successfully replaced and met all the property requirements for that kind of application. And the shrinkage value is the one factor which is it is almost nearer to that, but it is not exactly equivalent to what the polyester shrinkage value is. So rest all the mechanical properties and your impact properties, all we can able to meet. And coming to the commercial aspects of this grade, actually we have yet to launch this grade, and we will be looking for a compounding partner to go ahead with the launch of this grade. And it is a business decision that has to be taken by the management for the launch of this grade. We will soon launching this grade. Yeah.
I have another I would like to have another clarification. You said that recyclate 11 MF5. Is it the recycle is done by IOCL or you have a special grade something?
Currently, we have some business associates IOC directly not involved in recycling, but IOC involves in entire, the business associates will submit the samples to us, and we ensure the quality and the consistency of the recyclate, and then we market the product to the customer. Currently, IOC taken the role of assuring the quality and consistency, and in future we may think of, but currently we are doing along with the business associates.
Thank you, sir. I have another clarification. This POM replacement with PP.
Yeah.
So we have certain products now, as you rightly said, the cost of POM is globally increasing and very difficult to manage the supply, getting the supplies. So if we have a product, can you do that product testing, or will you assist us technically so that we can convince our OEs to change over?
Yeah, definitely. Actually, we will support with whatever the quantity of trial requirements also, we will support, we will share, give the material to you, and you can have the trial and give us a feedback that whether it is meeting your product requirements, or we can further improve based on your feedback. Currently, whatever product we have tried, it is being met, and the product purpose has been able to easily can replace polyacetal with polypropylene compound. So we can jointly work together on this, and we will give the material also, like formally compounded material.
Hello, this is Brahmarishi. We are from Premier and Sigma Industries, where we do plastic molding for automotive, medical and consumer goods. Plastic has been a magic material since its inception. It has been used for various activities like bottles to spacecraft heat repellents. But the problem we face is that our generation has been polluting a lot, and we've been facing a lot of backlashes for that. So my question here to the panel is, how can we, the plastic industry as a whole, separate waste at the source at our facilities or our local communities?
What do you mean is how to collect this? Or
how do we collect? Collecting the waste at the source would be a much efficient way. So how do we do that more frugally? And when talking about the carbon footprints, it's going to cost us a lot more when.
I'll give you one example for this. For example, this bottle for PET. Actually, this needs our society together to do some work. For example, if we take this, we need to separate. This is PET. This is polyethylene, some label. This is PP. So after in Japan, after we drink this, then we'll peel off this. Because if this is inside the PET, the property will reduce a lot. Also, the PP need to separate. Because by manual it's very easy, 1 second. But our industrial machine is very difficult. So that's why in Japan, all the people after drink, they will separate, then put on different place. So then we can collect this separately, then to recycle. So like this PET, I think already used for the carpet in the auto. This is recycled. It's very easy to make some fabric, then to recycle. So I think for this kind of, it's not only by company, from the society, from every person should have this kind of awareness how to separate this different material. Then from industry, then we can organize some center who can collect this material, this part, then come to the pretreatment plant to do the recycle. Maybe it's chemical, maybe it's physical. So anything, how to separate, how to collect, this I think is most important.
Good morning, myself Arun Kumar from Sarshan Pipes. I have a question to Mr. Suresh Mani. Sir, for the last 2 decades, the piping industry is going with the polymers. We have been producing polypropylene pipes. We are raw material part, we are depending on the imported and another one supplier. But we have been expecting from Indian Oil regarding our grade, polypropylene random copolymer. When we can expect it from Indian Oil? That's my question. Thank you.
Sir, with respect to that, a polypropylene copolymer for a pipe applications, like pipe applications, actually we have one grade like 4015 EG, and which can go for sheet as well as pipe. And also if you are looking at a pipe compound or any kind of special grades for pipes, then we can work it upon. And for the copolymer capacity you are looking at, like we have currently, we have a copolymer production only at Panipat, where it is one single line which can produce close to 30,000 tons of material. So we are going for an expansion, and you will have the additional, we are doubling our capacity of copolymers, and you will have sufficient amount of availability by 2025. That kind of assurance we can able to give it to you. And for the particular grades perspective, we can jointly work together to identify the grades, and we can support you on this. Thank you.
Thank you. With that, we conclude our session 1. We shall now break for a hot cup of chai. I request you to come back by 15 minutes. Happy networking.